So first we'll be seeing the definition of Mealy machine and then we'll see a problem related to it. So Mealy machine, it is a finite automata with no final state similar to the Moore machine, and it also produces the output sequence for a given input sequence. The difference is here the output symbol is associated with each transition. So when we move from Q0 to Q1 or Q1 to Q2, then the output will come. So it is associated with each transition. So output has to be on the transition and not in the state. So mathematical definition, it is similar to Moore machine. M is equal to Q summation delta triangle delta lambda Q0. So Q is finite set of states. Summation is the input alphabet. Then we have the output alphabet given by triangle. Then delta transition function, which is similar. Q into summation gives us Q. Output mapping here, it is different. Q into summation gives us the output. So what does this indicate? There will be another table that will come in because it is associated with a transition. Like Q into summation gives us Q. So this table will also have the Q as well as the summation, that is states as well as the input to give us the output. And then we have Q0 for the start state. So we'll see an example through which it will be more clear. So question says, design a Mealy machine which gives output as A if input ends in 101. Now the input is ending in 101 and B otherwise. Now we are designing a Mealy machine here. Previously we had done a Moore machine for 100. Here we'll be designing a Mealy machine. So logic input is in terms of 0 and 1. Output is in terms of A and B. Certain set of states will require as it is ending in 101. So first we start with 0 and 1. Q0 is associated with 0. Q1 is associated with 1. Then we have Q2 associated with 1, 0. Then Q3 here will be associated with 1, 0, 1. Now we will check whether the transitions are correct or not. There will be few changes that will happen. So we'll start with that. So initially we are having 0, another 0 comes in. So there is no state for 0, 0. So there is no state. Single 0, there is a state Q0. 0 is already present, 1 comes in. 0, 1, is there any state? No. Single 1, yes, there is a state Q1. So we get Q0 and Q1. Initially 1, 0 was present. 1 was present. 0 comes in. 1, 0. Yes, there is a state representing 1, 0, which is Q2. Then we are having 1 already present. From the input 1 comes in. 1, 1. There is no state for 1, 1. Single 1. Yes, there is a state. Q1 is there for single 1. We are already having 1, 0. Another 0 comes in. So 1, 0, 0. Is there any state for 1, 0, 0? No. For 0, 0 also there is no state. For single 0 there is a state, that is Q0. 1, 0 is present, 1 comes in. So 1, 0, 1, there is a state for it, which is Q3. That's why we write Q3 here. We are having 1, 0, 1, 0 comes in. So there is no state for 1, 0, 1, 0, 1, 0. For 0, 1, 0, is there any state? No. For 1, 0, yes, there is a state which is Q2. 1, 0, 0, 1, 0, 1, 0, 1, and 1 comes in. So it becomes 1, 0, 1, 1. Any state for 1, 0, 1, 1? No. 0, 1, 1? No. 1, 1, there is no state. Single 1, yes, there is a state which is Q1. So this will not come. This was there for Moore machine. Now instead of that, we'll be having the output mapping. So this is the transition function. Output mapping here, it will be little different. So if you see the output mapping, it tells Q into summation gives us delta or the triangle, the output. So we'll have to make the table similar to this, and then we will understand how it works. So here we are having state versus the input. Input is in terms of 0 and 1. We start with the state Q0, then we have Q1, Q2, and Q3. Now, if you see here Q0 to Q0, there is a transition that is happening. It was happening on getting 0 as the input. So, if you see in the problem, it is given only 101 should be mapped to capital A, otherwise, it should be mapped to B. So, there is no input as 101. So, input, if you see, it is 00. So, that is given by B. So, we were having here 00, that is given by B. Then 0, after that 1 comes in, we get a combination 0, 1, which is not given in the problem. So again, the output will be B. Q1, we are having 1, 0 comes in, 1, 0. Yes, there is a state for 1, 0. We go to that state Q2, but the output will be B. We are having 1, another 1 comes in, 1, 1, there is no state. And there was no state. We were having a state only for 1, that is Q1. But 1, 1 combination doesn't give us output as A. 1, 0 is present, 0 comes in, which becomes 1, 0, 0. So again, the output will be B. 1, 0 is present, 1 comes in. In this case, it is similar to the sequence given in the question. That's why we make it as A. In all other cases, it is B. So this question is little simpler. Only this change is there. Otherwise, all the cases, it will be B. Now we will verify this with an example as it is ending in 101. So suppose we get 1010. So we'll keep both the tables in front of us. Or first we'll draw the transition diagram and then we will see an example. So that will be better. So keeping both the tables in front, we'll draw the transition diagram. As I said, the transition is from one state to the other and the output is associated with the transition. So Q0 is the start state. Then we are having Q1. So initially Q0 to Q0, there's a input 0. What is the output? If you see here, it is B. So it will be associated with the transition. Q0 to Q1 on getting 1 as the input. So on getting 1 as the input, we go to Q1 and the output associated is B. Q1 on getting 0 as the input, we go to Q2. Output associated is B. So 0 slash B. So that is the difference in Mealy machine. Q1, when we get 1 as the input, we have output associated as B. Q2, when we get 0 as the input, we move to Q0. Output associated is again B. Q2, when we get 1 as the input, we move to Q3. That time the output associated is A. Q2, when we get 0 and 1 we have covered. Q3, when we get 0, we go to Q2. Output associated is B. Q3, when we get 1, we go to Q1. Output associated is B. So we have covered. So we go row wise again. This is the difference in the diagram for Mealy machine. Moore machine, it is present inside the state. Mealy machine, it is present in the transition. So that you need to remember. And we'll see an example, whether our logic is correct or not. It can be verified by an example. We will see the example. Ending in 101, output will be A. So we'll see, we will take an input 101 only. So it should give us output as A, final output, not the intermediate output. Q0, when we get 1, Q0, when we get 1, we go to Q1. And output associated with this is B. Q1, when we get 0, we go to Q2. Input 1 is remaining. Output associated is B. Q2, when we get 1, we go to Q3. and the output associated with this is A. So given input sequence is 101 in this case, and output sequence we get it as BBA. So in the end, we are ending with 101. That's why we get the output as A. Is this clear? So if you observe here, we are having 3-bit input, we get 3-bit output. So input sequence is 3, output sequence is also 3. In Mealy machine, that's the case. Moore machine, it was, if you get input sequence as 3, you'll get 3 plus 1, that is 4. So that is the point of difference between Moore machine and Mealy machine.